Okay guys, so today we're going to learn how to find the angle between two vectors. So here we have a diagram. We have a vector, let's call it u, negative 1, 2, and then another vector, let's call it v, 2, 3. The angle between them is something that sometimes can be, in various applications, can be interesting to know, various physics or what have you type applications. Now, we already learned how to find the angle of a vector in general. So, for example, we could find this angle right here, and we could find this angle right here. And with a little common sense, you could subtract them to find this angle here. So you could already do this based on knowledge you already have. Oops, didn't mean to do that. But that does take quite a bit of work, and you have to do the whole 180 in some quadrants and 360 in another quadrant, and you don't have to deal with all that. So it could be done, but this formula here has been established that also accomplishes the same thing. So what does this say? In case you've forgotten anything. So cosine of theta, theta is going to be the angle between vectors. So we only calculate one angle. We're not going to calculate two angles and subtract them. U dot V, so this is the dot product that we've learned, divided by the, well, what's this? Okay, so the things that look like absolute value bars, but there's two of them. This was magnitude. So that's basically the square root of x squared plus y squared, Pythagorean theorem. So magnitude of u times, this isn't a dot product, remember magnitude is just a number, so here this dot just means regular multiply, and then the magnitude of v. And then of course, to isolate theta, to solve for theta, we're going to be doing the inverse cosine of this whole thing that we see up there. So let me write that u a little neater. This is essentially the formula that we're going to be using throughout this whole process. So one formula through the whole thing. And you've come a long way in math. You know that if you've got a formula, you can plug in numbers and find an answer. I have full confidence that that's something you can do. So I'm going to be doing the evens. There are, what, 10 of them, 10 problems total, so 5 evens. You'll be doing the odds. Some I gave as diagrams, others I just gave the numbers, but you do them the same way. So let's look at number 2. First, we're going to need to find the magnitude of each vector. So let me do this. Magnitude. The first vector is going to be the square root of negative 5 squared plus 2 squared. So that's going to be the square root of 25 plus 4 square root of 29. I could type that into the calculator and get a decimal approximation, but we're going to be using the calculator for the inverse cosine anyway, so let's just hold off. Let's keep this in radical form just for the time being, sort of short term. I need to find the magnitude of the other one, so that's going to be negative 2 squared plus negative 9 squared. That's the square root of 4 plus 81, square root of 85. So I have the magnitude of each one. Now let's do the dot product. Negative 5, 2, dotted with negative 2, negative 9. That's going to be negative 5 times negative 2 plus 2 times negative 9. Okay, I realize that negative 5 doesn't look like a negative 5. Let's fix that. So this works out to be 10 plus negative 18, which is negative 8. Yes? I guess when I check myself, I'll know for sure. So now, to figure out theta, I need to do the inverse cosine of negative 8 over square root of 29 times square root of 85. If you look at that and you say, oh, you can't have a radical in the bottom of a fraction, we're going to use it. We're actually going to calculate this out. We're not trying to say that this is our final answer, so don't worry about that. It's not a problem. Let me make sure I'm in degrees. That's important. Excuse me. So inverse cosine, where is it? Right there. I'm going to hit a fraction bar. On top is going to be a negative 8. On the bottom is square root 29 times square root 85. And I get approximately, let's use those wavy equal signs for approximately because we'll be rounding off. Does it say where to round? No. Let's call this 99.3 degrees, or 27. Let me scroll down and check the answer key and see. 99.27. Oh, look, I lied. There's 12 problems. 3 pages. Sorry about that. So I'll go ahead and change this to 27. And there it is. Okay, if this one example is all you need, then by all means, stop the video and go ahead and get to work. If you want to see repeated examples, that's what I'm about to do. Okay, here goes. So let's do the magnitude of the first vector. So that's 1 plus 5, right? 2 squared, no, 2 squared is 4, not 5. I'm smart. So that's radical 5. Magnitude of the second vector, 1 squared plus negative 6 squared. That's 1 plus 36, radical 37. Now the dot product is 1 times 1 plus negative 2 times negative 6. That's 1 plus 12, which is 13. So theta is going to be the inverse cosine of 13 over radical 5 times radical 37. So function, inverse cosine, fraction bar, 13 on top, radical 5, oops. You know what? You can actually, it'll be easier to do on the calculator. You can actually call this radical 5 times 37 under one radical bar, and it'll be the same answer. So 17.1 degrees should be it for number 4. 17.1 degrees. All right, number 6. So magnitude, 3 squared plus 9 squared. That's the square root of 9 plus 81, square root of 90. And again, you could simplify this. You could type this into the calculator, but you don't need to. Just leave it like that. 5 squared plus 5 squared. Radical 25 plus 25. Radical 50. And the dot product is going to be 3 times 5 plus 9 times 5. 15 plus 45 is 60. So theta is going to be the inverse cosine, 60 over radical 90 times 50. So inverse cosine, fraction bar, 60 on top, 90 times 50 on bottom, approximately 89.24 degrees, rounding correctly. Number 6, where am I? Oh, whoa. Okay, that's not right. Number 6, 26.57. So I made a mistake. Ugh, that never happens. I always do things right. Oh, I forgot the radical down here. 90 times 50. Delete that. And there it is. Okay. Forgot one button, and that makes me wrong. 26.57 degrees. Okay. Number 8. So no drawing here, but that shouldn't matter. So the magnitude of the first vector is negative 9 squared plus 8 squared. What is that? 81 plus 64. Square root of 145. Magnitude of the second vector, 5 squared plus negative 5 squared. We just did one like this. 25 plus 25. Radical 50. The dot product, negative 9 times 5 plus 8 times negative 5. I'm going to use a calculator for that. Negative 9 times 5 plus 8 times negative 5, negative 85. So theta is going to be the inverse cosine of negative 85 over radical 145 times 50. So function inverse cosine, fraction bar, negative 85 on top, square root 145 times 50 on bottom. Ooh, that's weird. 176.63 degrees. Let's see if that's right for number 8. Yep, looks good. Oh, I should mention something. So I'm going to scroll back up to my original diagram. Technically, there are two angles created by two vectors. Oops, didn't need to erase quite so much. Doggone it. Oh, geez, I'm just dangerous with this eraser. Okay, here goes. So theta is the vector between them, or the angle between the vectors. Technically, there's another angle out here. This method will never give the large angle. It will only give the angle that's less than 180. If for some reason you needed the other angle, you would just subtract your answer from 360. But on the assignment, that's never going to be an issue. So just thought I'd throw that out there. Okay, number 10. Let's see. So magnitude of the first vector, square root, negative 7 squared plus 5 squared. That's the square root of 49 plus 25, which is radical 74. Magnitude of the second vector, 6 squared plus negative 7 squared. That's 36 plus 49. That's at 15, carry the 1, square root of 85. Dot product, negative 7 times 6 plus 5 times negative 7. What is that? Negative 42 plus negative 35, negative 77. So theta is the inverse cosine. Negative 77 over square root 74 times square root 85. Inverse cosine, fraction bar, negative 77 on top. And once again, you can just use one radical on the bottom. It'll work out the same way. And I get approximately 166.14 degrees. Let's see if number 10 is right. There it is. I'm sure by now you got it. I don't know if anyone's even watching the video at this point, but I'll finish. All right, magnitude, negative 7 squared plus negative 1 squared. Square root of 49 plus 1 is radical 50. Next one, 7 squared plus negative 6 squared. That's 49 plus 36. What is that? 15, carry the 1, radical 85. Dot product, negative 7 times 7 plus negative 1 times negative 6. Negative 49 plus 6, two negatives equal positive, negative 43. So the angle between these two vectors is the inverse cosine of negative 43 over radical 50 times radical 85. Take that to my calculator. Fraction bar, negative 43 on top, bottom radical 50 times 85, approximately 131.27 degrees. And there it is. Easy peasy lemon squeezy. So do the odds if you haven't already started. Check yourself, submit your work, and by all means, of course, use Desmos. Contact me with any questions by the normal means, and have a great day.